Not $1,800, not a dealer appointment, not a full exhaust system swap, not a quarterly maintenance package that costs more than your first car payment, under $15. That is the number, a single bottle sitting on a shelf at any auto parts store in the country that keeps a Toyota or Honda catalytic converter alive past 200,000 miles. And it is not a magic additive, it is not a backyard hack, and it is not something you need a certified technician, a lift, or a single hour of labor to apply. It is basic chemistry documented in peer-reviewed engineering research and proven across decades of real-world fleet use by Japanese taxi operators who were quietly running their original converters to 400,000 and 500,000 kilometers while the Western automotive service industry was busy building billion-dollar businesses on replacing them. 99% of car owners will never know this exists. They will wait for the check engine light, feel the slow dread of that amber glow on a dark highway, hand over their keys at the service counter, and walk out of the dealership $1,800 lighter, and sometimes more depending on the vehicle. Dealerships collect between $1,200 and $1,800 per catalytic converter replacement, and that number multiplies across millions of vehicles every single year into a repair revenue figure that explains clearly and completely why nobody in that building has ever handed you a $12 bottle and told you the truth. The people collecting that revenue are not interested in you finding out there is another way. To understand why that $12 bottle works and why it has been sitting in plain sight for decades while the service industry looked the other way, you have to go back to where this story actually begins. Go back to Japan in the 1970s. The oil crisis had rewritten the economics of the entire automotive world, and Japan felt it harder than almost anyone. The Ministry of Transport was tightening emission standards faster than nearly any other country, responding to choked urban air in Tokyo and Osaka with regulations that forced Toyota, Honda, Mazda, and Nissan engineers to think about exhaust systems in an entirely new way. These weren't engineers designing for warranties, they were designing for survival. Their own company's survival in a regulatory environment that had no patience for converters that died at 80,000 miles. The pressure produced something remarkable. Fleet operators running Crown Comfort taxis through the grinding stop-and-go traffic of Japanese cities, high-ace vans hauling cargo through mountain passes and coastal highways, were logging mileage on original catalytic converters that Western mechanics would have called impossible. 400,000 kilometers, 500,000, the same ceramic substrate, the same platinum and palladium catalyst coating, the same converter that left the factory, still processing exhaust gases within emission specifications years and hundreds of thousands of kilometers beyond what anyone in Detroit or Stuttgart thought realistic. These were not exotic components. They were not upgraded aftermarket units. They were standard factory converters kept alive by something invisible in the maintenance logs. The deliberate, systematic elimination of every upstream condition that kills a converter before its time. The fleet operators were not smarter than Western mechanics. They had simply figured out, through operational necessity and obsessive record keeping, that the converter itself is almost never the original failure point. It fails because something upstream is destroying it, slowly, invisibly, over thousands of kilometers. And by the time the check engine light appears, the damage has already been done for months. The converter is the crime scene. The murder happened somewhere else entirely. A SE certified mechanics with decades of experience on Japanese platforms have confirmed this on record, in teardown analyses, in forum posts read by millions of car owners who still hand over their keys at the service counter without asking a single question. The EPA designed catalytic converters to last more than 100,000 miles. Federal durability standards, Title 40 of the Code of Federal Regulations, require that emissions control components meet performance thresholds across that full distance. The component is engineered to outlast most of what surrounds it, built around a ceramic honeycomb coated with some of the most catalytically active metals on the periodic table. It is not fragile. It is not a wear item in the traditional sense. Something specific and preventable is cutting it short, and that something has been generating service revenue every single day that the industry chose not to explain it. Dealerships earn between 40 and 60% above wholesale parts cost on catalytic converter replacements, a margin documented in consumer automotive pricing analyses and visible to anyone who has ever called a parts supplier and then walked into a service bay. The service bay smells like revenue. The estimate gets printed on clean white paper, slid across a laminate counter, and the total at the bottom sits there like gravity. Heavy, inevitable, unchallengeable. There is no line on that estimate that reads, "Here is the $12 alternative we could have recommended 30,000 miles ago." There never is. Prevention isn't profitable. Replacement is. So here's what actually kills catalytic converters. The real mechanism, the real chemistry, the upstream chain of damage that the service industry has spent decades treating at the endpoint instead of the source. The first killer is a rich fuel mixture. When an engine runs rich, delivering more fuel than the combustion process can fully burn, unburned hydrocarbons travel past the combustion chamber through the exhaust manifold and enter the catalytic converter, where residual oxygen triggers a secondary combustion event inside the ceramic substrate itself. Internal converter temperatures spike far past design thresholds. The ceramic honeycomb, engineered to handle normal exhaust temperatures, begins to crack and melt. That thermal damage is permanent, irreversible, and it has nothing to do with the converter's age, quality, or mileage. It is a combustion management problem wearing a converter's face, and it gets diagnosed and billed as a converter failure every single time. The second killer is oil consumption. Modern engine oil contains zinc dialkyl-dithiaphosphate, ZDDP, an anti-wear additive that protects metal surfaces under high pressure. It is essential for engine longevity. It is also lethal to catalytic converters. When an engine burns oil and pushes it through the exhaust stream, the phosphorus compounds in that oil coat the platinum and palladium catalyst surface inside the converter. The coating does not burn away. It accumulates layer by microscopic layer across thousands of kilometers until the catalyst surface can no longer trigger the oxidation and reduction reactions it was designed to perform. Efficiency drops. The OBD system detects the drop. The check engine light comes on. The diagnosis is a failed converter. The actual cause was oil consumption that went unaddressed for 20,000 miles. Third is coolant intrusion. A leaking head gasket, a cracked coolant passage, or a failing intake manifold gasket allows ethylene glycol and its silicate additives into the combustion chamber, and from there into the exhaust stream. Silicates are chemically devastating to catalyst coatings. They bond permanently to the active platinum surface and render entire sections of the substrate catalytically inert. A slow internal coolant leak produces no puddle on the driveway. It produces no overheating alarm. It produces a sweet, faint smell in the exhaust and a catalytic converter that dies quietly over 6 months while the owner notices nothing unusual. Fourth is fuel quality. High sulfur fuel, common in lower grade pump options and in regions with less stringent fuel standards, degrades the platinum and palladium catalyst at the molecular level through a process called sulfur poisoning. The damage is cumulative. The difference between top-tier certified fuel and the cheapest available option compounds over tens of thousands of miles into a measurable, documented reduction in converter efficiency and lifespan. Every one of these failure mechanisms is preventable. Every one of them is what the dealer's service department is counting on you to either ignore or misunderstand until the damage is done. The Japanese fleet operators in Osaka and Tokyo were not ignoring them. Toyota taxi operators running disciplined programs, top-tier fuel, regular oil consumption monitoring, careful warm-up cycles on cold mornings, avoiding cold short trips under 5 kilometers that never allow the converter to reach its 400 degrees Celsius operating temperature. We're seeing converter lifespans that stretched into territory Western fleet managers considered unrealistic. Fleet maintenance logs from those programs document the results. The discipline was the technology. They weren't using expensive parts. They were removing the conditions that create failure. Now, here is where the story takes a turn that should make every car owner genuinely specifically angry, because it involves a diagnostic code that has quietly cost drivers across the world billions of dollars in repairs that were never necessary. When your catalytic converter begins failing, your check engine light activates and your OBD2 system logs code P0420, catalyst system efficiency below threshold. That exact code, P0420, the same amber light, the same readout on every scanner from a $25 unit to a $5,000 dealer diagnostic system. also appears when your downstream oxygen sensor is failing. The downstream oxygen sensor costs between $20 and $80. The catalytic converter costs between $1,200 and $1,800. Both failures generate P0420. Both sit behind the same check engine light. The sensor takes 20 minutes to replace with basic hand tools. The converter requires lift time, exhaust work, and labor billed at $100 to $150 per hour. NHTSA consumer complaint databases contain thousands of documented cases of converter replacement that failed to resolve the P0420 code because the sensor was the problem the entire time. Mechanic forums, OBD2 diagnostic documentation, and independent automotive research all confirm that P0420 misdiagnosis is among the most expensive and most common diagnostic errors in the repair industry. Same light, same code, a $1,700 difference hiding inside one diagnostic step that costs nothing with the OBD reader already in your glove compartment. That is the first twist. The second twist costs $12 and has been sitting on the shelf next to the motor oil for decades. The Society of Automotive Engineers, SAE International, has published peer-reviewed technical research on the effect of polyethylamine-based fuel system cleaners on injector deposits and combustion efficiency. PEA cleaners work by chemically dissolving the carbon deposits and varnish buildup that accumulate on fuel injector tips over time, restoring the precise spray atomization pattern the injector was engineered to produce. A degraded injector tip produces a coarse, uneven spray. Uneven spray means incomplete combustion. Incomplete combustion means unburned fuel in the exhaust stream, which means unburned hydrocarbons entering the catalytic converter, elevating internal temperatures and accelerating exactly the substrate degradation described above. Chevron Techron contains PEA. Several other widely available formulations do as well, and the ingredient is listed on the label. Price per treatment, $8 to $15 at any auto parts retailer. Recommended interval, every 15,000 kilometers, or roughly every third oil change. The mechanism is documented. The chemistry is peer-reviewed. The result: fewer unburned hydrocarbons reaching the converter, lower internal converter temperatures, preserved catalyst surface integrity. Follows directly from the engineering. The dealer service menu has never listed it. It has never appeared on a recommended maintenance schedule handed to a customer at a service counter. It is not in the owner's manual addendum. It generates no labor hours, no parts markup, no line item on an invoice. It costs $12. Consumer Reports longevity analysis on Toyota Camry, Corolla, and Honda Civic platforms consistently shows the same pattern. The highest mileage examples, owners publicly documenting 300,000 miles and beyond, logging maintenance records in online communities and enthusiast forums, are almost universally defined by strict OEM maintenance adherence, proactive oil consumption monitoring, and quality fuel use. High mileage Camry owners who have crossed 400,000 miles on original drivetrain components are not anomalies. They are the logical outcome of removing the upstream conditions that the industry profits from leaving in place. These are not lucky cars, they are disciplined ones. Now run the actual numbers. Catalytic converter replacement at a franchise dealership, $1,800 conservatively. Total cost of systematic prevention across 100,000 miles. Top tier certified fuel over the cheapest pump option. Approximately $200 in marginal cost difference across that full distance. PEA fuel system, cleaner at the correct interval, roughly $60 total. A personal OBD2 reader to pull your own codes before any service advisor touches the conversation, $25, purchased once. Regular oil changes to monitor and control oil consumption, already budgeted into your maintenance schedule. Total prevention investment over the full useful life of the converter, under $300. $300 in applied knowledge versus $1,800 in preventable failure. The industry invoices the second number millions of times per year. Here in order is everything. When P0420 appears, test or replace the downstream oxygen sensor before any discussion of catalytic converter replacement. A 20-minute job that costs under $80 and eliminates the most expensive misdiagnosis in routine automotive repair. Add a PEA-based fuel system cleaner every 15,000 kilometers. Pour it into a near-empty tank before filling up. Let it it run through the entire fuel cycle. Eliminate habitual cold short trips under 5 kilometers. A catalytic converter that never reaches operating temperature accumulates deposits with every incomplete warm-up cycle, building the hydrocarbon load that eventually overwhelms the substrate. Address oil consumption immediately when blue smoke appears in the exhaust. A single oil burning event is catalyst poison entering the exhaust stream with every combustion cycle. And delay is not a maintenance strategy, it is a converter replacement on a slow countdown. Use top-tier certified fuel, a real, verifiable industry program with publicly available brand lists that guarantees minimum detergent additive concentrations proven to reduce injector and combustion chamber deposits. Inspect the coolant system annually, because a slow internal leak leaves no puddle, triggers no alarm, and destroys catalyst coatings across months of invisible contamination before any external symptom becomes obvious. 6 steps, all of them cheap, all of them documented, none of them on the service checklist that gets handed to you with a smile and a complimentary coffee. The EPA's durability standards, the SAE's fuel system research, 4 decades of Japanese fleet maintenance records, NHTSA's complaint database, and the documented longevity of Toyota and Honda engines maintained with discipline. Every data point runs in the same direction. The knowledge was never sealed in a laboratory or buried in a patent filing. It was in Toyota service bulletins, in Japanese automotive trade publications, in the maintenance logs of taxi fleets that kept the same converters turning for 500,000 kilometers through conditions that should have destroyed them. It just was not something the repair industry was structured to repeat. So now you have it, the $25 OBD reader in your hand, the $12 bottle on your workbench, the 6 habits that a Crown Comfort taxi operator in Osaka applied every single day while the dealership down the road was writing $1,800 estimates on the same failure he never had. Not $1,800, not a dealer appointment, $12 and 6 habits. That was never a secret, it was just something nobody was paid to tell you.